Hello everybody. Here I am again, myself Dr. S.D. Chauhan, Department of Physics, Adarsh College, Hingoli. In previous session, we have seen the waves and basic fundamental things regarding the waves. Already we are on the way of waves and oscillation, paper number 6. Now let's see, today also we will see a little bit introductory, some important factor which are useful for our syllabi, what exactly it contains. In the previous session, what we have seen, that will also we will revise little bit. So this is what exactly we have seen in the last session, that what is mean by as an wave, very fundamental thing in which we have seen what is the wave motion, and that factor how what exactly meaning to be as an wave is to be there. As simply we know that wherever the we can say steady medium is to be there, and we are disturbing it through the any external applying the force, and that means to be as an steady medium that contains the surface layer to be as an steady particles are to be there, that will get disturbed and the vibrations are created in the particle, and that will vibrate with the repeated and periodic motion is to be there, and that is somehow it is nothing but to be called to be as a wave motion is to be there. Whatever be the particles vibrations are there, that vibrations of the particles are to be with the repeated and periodically, and that is how this wave motion is going to be generated. Simply again, this all type of the mediums, either it is to be as an air medium, water, or any type of the other medium is to be there. It is not necessary that every medium that will show this wave motion phenomena. There are certain things that is to be very much important as far as this wave should be generated, and for that we have seen the basic three parts are very important as far as the wave motion should be created in that medium, and for that we need that medium should have inertia, elasticity, and the very negligible frictional resistance is to be there. As far as these three parts are to be there, or the properties are to be there, already possessed by this your water as well as the air is to be there. Inertia, elasticity, negligible frictional resistance, it is already having for the your water as well as the air particles are to be there, and that's why the wave motion is generated as in the water as well as in the your air medium, and these are the basic things for generation of the your wave motion is to be there. Related to this, the important factor wherever we can see in the definition, wherever the wave is going to be generated, the particles are not moving, or the basically the particles are vibrating at their mean position, and that is somehow there is no transfer of particularly matter is to be there, only the transfer of the momentum and the energy is to be there, and that's why we have already seen in detail how this momentum as well as the energy is going to be transferred, but the matter is not going to be transferred in that case, and that's why we can say that these are the basic properties as far as the as far as the propagation of the wave is to be there. As the wave is going to be propagating, there are two types of the things are to be there. The waves are of two types. The first one is to be as an transverse wave, and the another one is to be as an longitudinal wave. As far as the transverse wave is going to be concerned, if suppose the wave's direction is going in this way, that is the propagation of the wave is in this way, and at this stage the vibrations of the particles are perpendicular to the direction of the propagation of the wave. That means if the wave is moving from this to this, and the particles vibration will be perpendicular to this, likewise this, and in this way if the particles vibrations are perpendicular to the direction of the propagation of the wave, that time we can say these type of the waves are nothing but to be your transverse waves. And basically example for these transverse waves are your air particularly air particles, and as far as the electromagnetic waves are to be there. As far as the longitudinal waves are going to be concerned, the longitudinal waves are those type of the waves where the particles vibration is direction to the direction of the propagation of the wave, means to be as an through and fro. If suppose the direction of the propagation of the wave is in this way, the particles vibration will be forward and backward, forward and backward. Likewise, this particle will vibrate in this likewise through and fro to the direction, along the direction of the propagation of the wave. And that's why such type of the particular waves are nothing but to be called your longitudinal waves. And as far as the simple example for this particular longitudinal waves are nothing but to be your sound waves are to be there. That is also we have seen in detail. Now again, what we have seen related to the these waves, the basic properties, that is to, or the characteristics also we can say. As far as the waves, if you look at the waves are what exactly it contains, the very important thing, that is nothing but to be, it is wavelength is to be there. Now what exactly the wavelength is to be there? To define this wavelength is simply whatever the wave is going to be the distance traveling in the one complete vibration of that particle is to be there. Now let's see what exactly the complete vibration of the one particle is to be there. Suppose this is the mean position and the particle vibrate at its own mean position, from its mean position. That means the complete vibration of the particle is wherever you are throwing any stone in that pond, that is what the particles are going to be deeply down max point, again coming back to the mean position, again it goes up max up, and again it goes to the back to the mean position. This is what one complete vibration of that particle. Now while doing this one complete vibration of the particle, the wave travels certain distance, and whatever the distance traveled by that wave within this particular one vibration, that is nothing but to be called your wavelength of that wave is to be there. So this is how it is shown in this diagram also. If you look at this part here, and this up to this distance is nothing but to be called as a wavelength, and it is denoted by, that is called to be as an your lambda is to be there. Now again, related with this, again to be wavelength, whatever be the amplitude part is to be there. Now amplitude is simply as the particle is disturbed, or the particle moves from its mean position to max peak or max down. So whatever be the, it's moving from the mean position to max up direction, that is nothing but to be the amplitude of this particular wave is to be there. So this is what the amplitude shown here as, likewise this is what the amplitude for this. So this is how again to be as an amplitude, sorry, this one is to be as an amplitude for this center point is to be there. So in this way, what exactly meaning to be as a maximum displacement of the particle from its mean position to extreme position, either it is up direction or either it is in down direction is to be there. So this is what the amplitude for this case. Now secondly, again we have already discussed vibration means what. Still vibration is nothing but to be the particle from its mean position goes maximum upside, again comes to back to its mean position, again goes to the maximum deep downside, and again comes to its mean position. This is what the, and vice versa, this vibration is going on and on. This is what the complete one vibrations is to be there. As far as the frequency characteristics is going to be concerned, we can say that whatever the number of vibrations taken place in 1 second, that is nothing but to be called its frequencies to be there. So number of cycles or number of vibrations in 1 second, that is nothing but to be its frequency, and it is denoted by n, and here it is to be the n part where it is to be denoted by. Secondly, the time period is to be related with this frequency is also to be there. As the one complete wavelength, one particle's complete vibration is going to be there, whatever the distance traveled by that wave is nothing but to be called your wavelength, and the time taken to complete this one vibration is nothing but to be, or complete one vibration is to be there, that is nothing but to be time period. And as far as for the one wave, whatever the time is taken, that is nothing but to be your time period is to be there, and this is also denoted by the T is to be there, capital T. And there is a relationship as far as the frequency and your particularly time period is to be there, that is inversely proportional to each other. As far as this last part, that is to be as an phase, what property is to be there, it is simply nothing but to be the displacement of any part. It is nothing but to be a ratio as far as the whatever it may be, that to be as an particles vibration at any instant, that particles vibration particle displacement at any instant in that wave, to the whatever be the amplitude, and that is what nothing but to be your phase is to be there. As far as one complete when the two particles are set into phase, when they are having the phase angle in between them, that is to be as in 2 pi, that is half cycle with this. And if you look at this is to be as in these two particles, this one and this one, are called to be in the phase, because if you look at this is quarter and this is quarter, it will become half, this half and this half, it will become to be as in one complete circle, and one complete circle is having the 2 pi angle, that is the 360 degrees to be there, and that's why the phase angle is 2 pi in between them. And in that case the two particles are said to be at the both the particles are in phase are to be there. So this is what the basic fundamental things we have seen in the previous session, which are very important. With this case, again, another relationship is to be very much important to understand the equation point of view. So first of all, what exactly the part it is to be having to be your time period, that is t, and your frequency. What exactly the correlationship or relationship it is in between them is to be there. To understand this, as far as the time taken to complete n vibrations, if supposed to be 1 second, wherever it is very simply to understand, as far as the your tuning forks, if you have done the experiments at the 12th standard, whatever the tuning forks you have used, it is having one number, either it is 512, 342, whatever it may be, the number is to be there. What it indicating is that whatever the number written on that tuning fork, that means the number of vibrations are generated in 1 second through that tuning fork. That is what its frequency is to be there. And if suppose the time taken to complete n vibrations are to be suppose 1 second, that means to be as an if suppose I have the 20 vibrations in 1 second, then if I want to find out the time for the particularly one vibration, if 20 vibrations in 1 second, and now I need whatever the time for the one vibration, I know 512 or 342 vibrations per second, that is its frequency. But now I want to find out the time for one vibration, that means 1 divided by whatever the it is number, that is 512 or 343 is to be there. That means if suppose the time complete n vibrations, n is to be as a variable number here taken, and in 1 second suppose n number of vibrations are taken place, in that case if suppose to time I want to find out the whatever be the time period for one vibration, or that is to be nothing but to be 1 by n simply, and that is what the time period is to be there. And if you have seen the as far as the for defining the time period, we always say that for completing one vibration, whatever be the time taken, that is nothing but to be your time period is to be there. Here it is also to be as an 1, that is complete one rotation divided by n number of vibrations, whatever it may be, that is what the time period is to be 1 by n is to be there. And if suppose it is nothing but to be, that's why this is clearly indicating as the t is equal to 1 by n, that means time period is always inversely proportional to the frequency. And if I want to show the again simply relationship is to be there, it is nothing but to be frequency into time period, it is always to be as an 1 is to be there. So it is n into t is equal to 1. Again, very one important relationship we have to understand, because that is very useful in our next calculation part is to be there. As far as you want to find out the wave velocity, either you want to find out the particle velocity, you need these relationships in future too, or you want the differential equation for the wave motion, or a number of things. If you want to calculate the energy for the your wave motion, whatever the parts are to be, or propagation of the wave is to be there, you need some relationship. As far as this relationship, that is the time period and the frequency is to be there, there is one another relationship between the your frequency and the wavelength is to be there. Now as far as the velocity part is going to be concerned, we are aware that the velocity is nothing but to be displacement with respect to time. And in simple way, if I want to find out, or if I want to represent it in a particular what you call as a mathematical point of view, the velocity is equal to distance upon time in roughly we can say. That means it is simply the velocity is nothing but to be displacement with respect to time is to be there, and that is what velocity is nothing but to be distance upon time in simply we write. Now here, as far as the wave is going to be concerned, what exactly the relationship for this frequency and the wavelength is to be there, that we are going to find out. As far as the wavelength, we know that it is the distance traveled by the wave within the one complete vibration, and that is denoted by lambda is to be there, and lambda is the distance traveled by the wave in one time period, and that is what the lambda is now become as a distance. That is what the lambda is nothing but to be, it is distance traveled by that particular wave. That's why here distance will become to be as an lambda, and time period is nothing but to be given with the capital T is to be there. Now if I want to find out the velocity, in that case that will be the velocity of the wave is to be there, and that velocity is nothing but to be given whatever be the distance upon time, and that's why the velocity small v here, if you look at, this is nothing but to be simply given as a your wavelength, that is the distance upon the time period T is to be there, and that's why v small v is nothing but to be velocity of a wave is to be there is equal to lambda by T is to be there. So it is what the case where simply you can understand what exactly the velocity of the wave is equal to wavelength upon time period lambda by T. But you know that already we have calculated the time period T is to be there, and time period is nothing but to be having inversely proportional to the frequency, that is T is equal to 1 by n. We already know that, and now T is equal to 1 by n we know, and if we are putting this value of T inside this lambda by T relation, we will get the exactly v is equal to lambda by T, that is what we have, the velocity, wave velocity is equal to distance upon the time period, that is wavelength upon time period is T is to be there, that is lambda by T, which if I am putting the value of T here, then the T value if I put, that is lambda by 1 by n, T is nothing but to be 1 by n, because T is inversely proportional to the frequency, that is 1 by n is nothing but to be your frequency, and that's why if I am putting this 1 by n here, then it will become relation lambda by 1 by n, and with this case simply it will become to be as an v is equal to n lambda. So this is what the relation you can say, it is the relationship for the your frequency and the wavelength is to be there. That means the velocity of the wave is equal to n lambda, that is frequency into wavelength is to be there. So this is what exactly the new relationship we have seen. Now we want to find out the equation of a simple harmonic wave. For that we have to consider few things. If suppose the wave is traveling from left to right, that is to be there, from this left to right, if suppose the wave is going to be traveling, in that case, so this is what the wave, the same relation I have taken, or the same diagram I have taken, the wave is traveling in this direction from the left to the your right is to be there, and this diagram is showing what exactly the particularly the wave is going to be traveling. Now we are considering one point. If suppose that at the beginning stage, if suppose this one is to be as an your O point, here it is supposed to be as an your at the beginning stage, if suppose this is for a consideration, this will be the simple way to understand because the wavelength is given here, so we will take here to be as an your O point as a here. So if suppose O point is here, you can take anywhere, that doesn't matter to be, and the particles or the wave is traveling from the left to right in that case. And now if I want to find out the relationship for the displacement of the particle, I can write y is equal to a sine of omega t is to be there. Y is equal to a sine omega t. A is nothing but to be whatever be the amplitude, here it is to be as an given with this case. Now this is what the amplitude for that particular we can say particles, y is nothing but to be displacement of the particle, a is nothing but to be amplitude, omega t is to be angular velocity, t is the time, small interval of the time is to be there, and this is given with the equation 1. Now we are considering, that means to be as an, here is the one wave is completely, here it is to be there. Now this is what the one wave here it gives you, this is one wave is to be there. Now as the displacement of the particle is relation given with y is equal to a sine omega t. Now consider one another particle A is to be there. Now what I am doing, from this O, this is our O particle is to be here, and what I am doing, I am taking one another particle at any instant that is to be there. If suppose I am putting this to be as an here, suppose this is the a position of the your particle A is to be there. So this is what the position of the particle A is to be there. Now at this stage, if suppose this is the particle's position A, at that point if I want to find out the particularly, and considering the another particle A which is at a distance x, very important factor is the distance in between them is nothing but to be given as a x is to be there. So distance in between the particle O and A is nothing but to be, means from this point to this point, the distance, sorry, this one is to be there. So this point to this point, this is your O point, and this is your A particle A is to be here, and the distance in between them is nothing but to be x is to be there. This is what the x. So in between them distance is x, and we have traversed with the velocity small v, as we know that small v it is written with the, and in that case if I want to write the displacement for the particle A, now whatever the displacement of the particle A, I will write y is equal to a sine, not here omega t, it will minus of alpha is to be there right now. So the one part it will added, that is to be alpha, that is nothing but to be the phase difference in that case. So what happens exactly in this case, if you look at in detail, now here is the same diagram again. We are writing the displacement of the particle for the A, and considering the particle O in between in the medium at the beginning stage. Now here the whatever be the displacement at A is nothing but to be y is equal to a sine omega t minus alpha is to be there, where alpha is nothing but to be phase difference. What is the phase difference in between case? I already told you that phase difference is nothing but to be the part we already discussed. When the two particles are said to be in the phase, these 2 points if I taken into account, these two particles are said in the phase when the particular path difference in between them is supposed to be as in 2 pi is to be there, and here the phase angle is to be as an in that case. Now alpha is taken as a phase difference in between the particle O and A is to be there. This is what we have taken here, particle O, and here we have taken particle A is to be there. So in this case A is to be here. So in this case whatever be the phase difference is nothing but to be 2 sorry is nothing but to be given with the lambda. So this is what the phase difference is to be lambda. Now as we know that when the two particles are in phase, the path difference or the phase difference is nothing but to be 2 pi is to be there, and the path difference is nothing but to be lambda. Now what exactly path difference? Already we know phase difference in between the 2 points is nothing but to be 2 pi. That means the angle in between them, that is phase angle, is different in between them. And as far as the 2 peak points, that is to be trough or crest, whatever it may be, they are having the path difference, that is value is nothing but to be lambda. That means the path or the distance in between them is lambda, and the phase is difference is nothing but to be 2 pi. As far as the lambda versus the path difference is going to be concerned, it is phase difference is to be concerned, it is 2 pi. But here we have taken the phase difference is alpha, but the path difference at that time, because O to A distance is how much? It is x. That's why in this case path difference is x is to be there. And what is the phase difference we have considered? That is alpha is to be there. In simple way, when the phase difference is 2 pi, the path difference is lambda. As far as whatever we consider the phase difference in between point O and A is alpha, that time the path difference is x, because distance between O and A is x, that we have taken consideration part is to be there. So if I write the relationship for the both the things, then I can simply write as an like this. This is what alpha by x means the ratio of whatever be the your, this is what the alpha by x means the path phase difference of between the two divided by the whatever be the path difference is equal to, for this particle A is to be there, is equal to 2 pi, that is the phase difference for the another particle divided by lambda, that is the path difference. Means phase difference divided by path difference, phase difference divided by path difference. This ratio is going to be continuous constant, and that's why I can write alpha by x is equal to twice pi by lambda is to be there. With that case I can calculate the lambda is to be there. So lambda I can write in that case twice pi into x divided by lambda is to be there. So this is what the case I can find out the alpha lambda. In that case you can say it is to be as an alpha simply. So here it is to find out the equation simply. If you look at, but we are again known to be as an omega, to be as an angular velocity is nothing but to be given with twice pi by t is to be there. So this is what the case where it is to be as an omega is equal to twice pi by t. Angular velocity, when I am talking about, it is the circularly in the fashion, because half wave and half wave, it gives you the circle, and the vibrations of the particles in that case in the form of a circle it is to be written, and angular velocity, that's why it is to be taken, that's why it is to be omega is equal to twice pi. It is the total path that is to be as an angle, that is to be 360 by t, whatever be the time period, and that is by t is equal to, again I can write this is to be as an twice pi. Here the t, if you know, t is nothing but to be again time period, and we know the time period is nothing but to be, again we are aware about that the relationship for the time period, that t is nothing but to be having the relationship to be as an your inversely proportional to the frequency, and that's why we are again aware about that whatever be the relationship for this case, this t I can write it is to be in the fashion of, as far as I want to write the relationship for the t is to be there, I can write it to be as an omega is equal to 2 pi v by lambda is to be there, because v is nothing but to be n lambda, I know that, and that is how it is nothing but to be t is to be here to be taken as a this, what the t is to be replaced with v by lambda, because if you look at, t is nothing but to be time period, v is nothing but to be velocity of the time, lambda is nothing but to be your wavelength, and v is small v is equal to lambda by t, that relationship is to be there, and t is going to be, that's why the t is replaced here with to be as an v by lambda by v, but it goes upside, that's why it becomes to be as an your v by lambda. But v by lambda, if you put this value, and in this case the whatever be the your, as you are known about with this relation, that is v is equal to n lambda, or whatever the frequency and the time period relation is to be there. With that case we can also write this relationship omega is equal to twice pi v by lambda. Now if we are putting these values in this equation number 2, that time whatever be the equation 2, what is that equation number 2? That is quite interesting. This is what the equation number 2, that is y is equal to a sine omega t minus of alpha is to be there, and if I am putting these values for omega, that is omega is how much, v is equal to n lambda, and what is the alpha, that is twice pi twice pi twice pi x by lambda is to be there. So putting this omega value here, and your alpha value is to be here in this equation number 2, I will get y is equal to a sine twice pi, here it is very important part, y is equal to a sine twice pi vt by lambda. This is the what the vt by lambda is to be there, minus twice pi x by lambda is to be there. So this is how this y is equal to a sine twice pi vt by lambda. So if common twice pi by lambda taken out, then the remaining part is vt minus of x is to be there. So in this case y is equal to a sine omega twice pi by lambda into vt minus x. This is what the your simple harmonic wave equation is to be there, or equation of simple harmonic wave is to be there. Now if suppose the particle is moving in opposite direction, or the wave is moving in opposite direction, that means what we have seen, the wave is traveling from left to right. Suppose the wave is traveling in opposite direction, this minus will become only plus, and the relationship will be y is equal to a sine twice pi by lambda into vt plus of x is to be there. So this is what the equation of a simple harmonic wave. before going to start our wave velocity and the particle velocities, these relationships are very much important. That's why we have taken in detail how this relationship or the equation of a simple harmonic wave equation comes, and relationship between the frequency and the wavelength and the time period is to be there. That is also we have seen in detail. So